Yeah, go ahead.
Hi guys, so we're GTP and here we are to present Quantum Heights Tower. I'm Karina.
I'm Jacob. I'm Peter. I'm Brian. And I'm Jorge.
So to begin at GTP, we are dedicated to delivering inventive and streamlined design solutions tailored to our clients' distinct requirements. Our primary objective is to guarantee that each project we embark upon is executed with the utmost precision, quality, all while being mindful of our environmental footprint. Our goal is to ensure structural integrity and prevent overloading, providing a safe and stable foundation for the entire building or structure. In doing so, we consider factors like material strengths, building codes, and safety standards to design column connections and support systems that effectively bear and transmit the loads throughout the structure. Column load takedowns involve the systematic analysis and distribution of loads carried by a structure's columns. This process includes determining the loads acting on a column, such as gravity, lateral, and other forces, and then efficiently transferring these loads to the foundation. So Quantum Height Towers is based on the Citibank building. This is located at the 399 Park Avenue in New York. Our company was tasked in redesigning a new building at the site of the Citibank for commercial and residential occupation. That Citibank building is a skyscraper that consists of 41 stories, essentially at 520 feet, with a floor area of 1,700,000 square foot. For our project, we decided to go along with a lot size of 81,025 square foot. Wait, let's just go back. Oh no, it's repeated. Sorry about that. So the building will be built to the New York Building Code and will meet all the design strength requirements as necessary, all while keeping the cost of materials into consideration. Peter will go more into depth about the codes that we have integrated in building this tower. So our project description will entail of creating a 40-story commercial office use building in Manhattan, New York. The typical bay is anticipated to be a 30-foot by 40-foot with columns spaced 30 feet on center. Our building footprint is based on taking the square footage with taking the typical floor ceilings of 15 foot. The overall height of the building is expected to be 600 foot. And calculating for the Quantum Height Towers, we developed a foundation system that supports the building loads considering the soil bearing capacity. Our composite gravity floor frame system will consist of beams, girders, columns to transfer the gravity loads into the foundation. We had also integrated a lateral system that will resist wind loads in the New York area, and in doing so, we will also provide a material quantity takeoff.
So this is our finished product's dimensions. We have a footprint of 32,400 square feet with 270 in the X and 120 in the Y. Like we said, the floor height is 15, and we're using an 18 gauge 3-inch metal decking with 4.5-inch concrete slabs with a total slab depth of 7.5 inches. And it has 2-hour fire rating. And for our foundation system, our plot is underlain with dense soil and soft rock. And we're using a mat foundation, which you can see an example of there, but it's not our exact mat foundation. And our structural design criteria is based off the IBC, and we're using AISC 360-16 for the specific specifications for structural steel buildings. And for concrete, we're using ACI 318-14 for all of our concrete structures. And these are some of the design dead loads and live loads based off those codes. For our floor finish, we're using residential, which is 5 pounds per square foot, and retail commercial for 20 pounds per square foot. And for some of the live loads that we're using, for example, we have the lobbies at 40 pounds per square foot. And then we're also using stairs and exit at 100 pounds per square foot. And these are some of the wind loads that we're going to be experiencing with exposure category C, with a basic wind speed of 115 miles an hour. And the base shear is in the X direction of 693 kips, and in the Y direction is 924 kips.
Okay, so here we have the gravity floor framing system. As I said before, the floors, we have 40 of them. The total area is 32 square feet, and the height is 600 square feet. 600 feet up. We're gonna include W-shaped I-beams, as well as for the spandrels, the girders, the columns. And we're also gonna have metal decking and the concrete floor system. The considerations are 4,000 PSI. We also have 6,000 and 9,000 PSI, because as we go up the concrete core, it starts changing, as you'll see later on. Then FDNY requires that we have minimum 2-hour fire rating on the metal deck slab, as well as the beam and the girders. And then all of the, everything that we've chosen is considered under economic consideration and resource availability. And then this is the typical floor plan. As we go up, it actually, the floors actually get smaller. So in the beginning, we have 270 feet by 120 feet from the first to the 20th floor. Then from the 21st to the 30th floor, we cut away 2 entire slabs. And then it becomes 210 by 120 feet. As we go up further, 31st to 40th floor, it's 150 to 120 feet. As for the gravity, as for the floor framing design, when we ran it through ETABS, we try to make it so that all of the beams would be the same. The columns, as you'll see later on, they all change as we go up, but the beams, for the most part, are actually all the same. So they're all W30 by 108. As we said before, the metal decking is 3 inches. The concrete depth is 4.5 inches. The dead load that we use is 20 pounds per foot. The superimposed dead load is 35 pounds per foot, and then the live load is 100 pounds per foot. These are the calculations that we did. I just made an Excel sheet and then just put in all the information that we had. So the dead load's right here, the 20. The superimposed is 35 pounds per foot. The live load, 100 pounds per foot. Then the beam length that we had was 40. And then for the tributary weight, that's where we use the 30, because it's, then we got 120 square feet. This is for the actual load, so this is the moment. And as you can see, all of our calculations are pretty much there. 54.9 kips is what we get for shear. 549 kips per foot is what we get for moment.